Hello everyone. My name is T.Bhuvana Darsini, studying second year in EC department with roll number 24BQ1804G7. Today my topic is about finite state machines. Introduction to FSM. Definition. A finite state machine is a mathematical model of computation that changes its state based on the input signals and previous states. It is a type of sequential circuit because its input depends on both the current input and the past inputs, which are stored as states. The key idea of FSM is memory plus combinational logic. Sir, combinational logic. Examples in real life is elevator control system, traffic light controller, vending machine logic. In these, we use FSM. Why we use finite state machines? Purpose of FSMs is to model systems that have memory, to design control circuits for sequential operations, to simplify complex digital logic into manageable states. Advantages of FSM are easier debugging and simulations, predictable and structural design, suitable for automation and embedded systems. Basic components of FSM. An FSM consists of three main parts: input, output, and state. Input are signals that affect the transition. Output are signals that result from the current state and inputs. State are memory element representing the current condition of the system. The logic diagram is as follows. We can observe that this is input and this is output going through a combinational logic circuit with memory element. Types of finite state machines. There are two types of finite state machines, Moore machine and Mealy machine. For Moore machine, output depends only on the current state. Changes occur after clock pulse. That means they are synchronous. They are easier to design and debug as well. For Mealy machine, output depends on both current state and input. Generally, these are faster as output can change immediately with input. If we talk about difference between Moore and Mealy machines, we can see that Moore machines are in Moore machines output depends only on current state. In a Mealy machine, output depends on current state as well as input. Moore machines are slower. Mealy machines are faster. More machines are easier to design, but Mealy are more complex. In more machines, output changes only after state changes. In Mealy machine, output changes immediately on input change. So, like if input changes, the output changes immediately. In more machine, the example is traffic light controller. For Mealy machine, sequence detector. A representation of FSM. FSM can be represented using state diagram, state table, equation. State diagram means a graphical representation showing transition. State table is a tabular form listing states, inputs, outputs, and next states. State equation, algebraic form used in a circuit diagram. Let's now take a sequence detector. Let's take detect 101. The objective is to detect the input sequence 101 in a series bit stream. Steps to detect these. First one is defining state. The first initial state is S0. Detector state 1 is taken as S1. Detector state 10 is taken as S2. And detector state 101 is taken as S3, which gives output is equals to 1. Transition. From S0, if 1, it goes to S1. From S1, if 0, goes to S2. From S2, if 1, goes to S3. Then we receive output as 1. For other inputs, go to appropriate previous states. The state diagram for detector is as follows. We can see that if we given 1, it goes to next state. Wait. If we given 1, it goes to next state. If we given 0, it goes to next state, and if we given 1 or 0, it goes to next state. Explanation is transition occurs based on the input bit. When the complete sequence 101 is detected, FSM produces output 1. State table for the sequence detector is as follows. We take present state, input, next state, and output. If present state is as 0, if the input is 1, then we goes to next state S1. Similarly, if we take all of this, only in one condition, we get output as 1. Remaining all conditions, we get output as 0. Applications of FSM. These are used in digital control systems, traffic light controllers, vending machines, elevator logic control, sequence detector, communication protocol designs, error detection and correction circuits. Advantages and limitations of FSM. If we talk about advantages, these are systematic. This follows a systematic design approach. These are easy to simulation and verification. Reusable logic for similar problems. These limitations are it may be too complex for with too many states. This needs clock synchronization. In asynchronous FSM requires proper state minimization to avoid redundancy. Conclusion. FSM forms the foundation of sequential circuit diagram. They describe how systems react to input sequence over time. Understanding FSM helps in designing real-world control system efficiently. Summary. FSM means controlled behavior plus memory plus sequence logic. Thank you.